Hello viewers, in today's class we are going to discuss yet another important and very conceptual problem from definite integrals, and here we have one more problem to solve. So we have to find the value of this integral from 0 to infinity, and the integrand is x log x divided by 1 plus x square whole square, right? So here we'll see how easily we can find out the value of this integral by making use of substitution method and some properties of definite integrals, right? So let us take this integral as I, right? Now see, here the first step is to make use of substitution method, right? And viewers, we know that substitution method is a very powerful tool in integration, right? So here let us substitute x is equal to 1 over y, right? So here why we are taking this substitution, that is x is equal to 1 over y, that is the reciprocal of y, that is 1 over y. Because see, here the limits of integration are from 0 to infinity, right? Now see, the lower limit is 0 and the upper limit is infinity, right? So when we take this substitution, then we can write y is equal to 1 over x, right? See, when x tends to 0 or x is equal to 0, then obviously y tends to 1 over 0, that is infinity, right? And similarly, when x tends to infinity, infinity implies that it is a large number, and y tends to 0, right? Because when x is very large, then 1 over a large quantity is tending towards 0, right? So the limits of integration are now from infinity to 0, right? So now let us differentiate this expression, right? So we'll write dx, and here we have the derivative of 1 over y, and this can be written as y raised to minus 1, right? So the derivative of y raised to minus 1 with respect to y is minus 1 over y square, and here we have dy, right? So dx is equal to minus dy over y square, right? Okay, so now we have this expression, then we have this expression, and these are our limits, right? So now we can write this integral I in terms of y, right? So we have the limits from 0 to infinity. So now we have the limits from infinity to 0, right? And for x, we can replace this x by 1 over y. So we can write 1 over y, then we have log 1 over y, and then we have 1 plus x square. So x can be written as 1 over y, so this is 1 over y square, and here we have square, and for dx we can write minus dy over y square, right? So now the original integral is represented in terms of y. So now let us simplify this expression. So we have 0 to infinity. Here we have infinity to 0. Then here we have 1 over y. Log 1 over y can be written as log of y raised to minus 1. So this is minus log y, right? Due to this property, that is the log of m raised to n is n log m, right? So here we have, for this term, we have minus log of y, right? And in the denominator, we have 1 plus 1 over y square. So taking the LCM here, we have y square plus 1 whole square, and then the square of y square is y raised to 4, right? And here we have minus dy over y square, right? Now let us simplify it further. So we can now write I as infinity to 0. Here we have this negative sign and this negative sign get cancelled. So we are left with log y. Then we have y square plus 1 whole square. And then this y square can be taken in the uh, numerator. So we have y raised to 4, and then this 1 over y, it gets the place here. That is 1 over y is here, and then we have this term, that is dy over y square, right? So now here we have 1, so 2 plus 1 is 3. So these two terms get cancelled with this one, and here we are left with 1y, right? So now we can write this integral as infinity to 0, and here we are left with 1y. So we have y, then we have log of y, and here we have y square plus 1 whole square, right? And here we have dy, right? Now we have one important property of definite integrals, which says that if we interchange the limits, then the value of the integral, it becomes negative, right? So if we have a to b, say f of y dy, then we can interchange the limits and keeping a negative sign in front of the integral, right? So we have b to a and f of y dy, right? So now if we interchange the limits here, then we can now write here infinity and here 0, and putting a negative sign in front of the integral, right? So now we have this expression, that is I is equal to negative of 0 to infinity y log y divided by y square plus 1 whole square dy. So now in integral number 1, let us apply one more property of definite integral, right? And that property is known as the dummy variable property, which says that if we have an integral, say a to b, and we have f of y dy, then if we change the variable from y to say t, right, then the integral remains the same, right? It means there is no effect on the value of the integral if we change the variable, right? So to make it more clear, let us take an integral, say 1 to 2 x square dx, right? So the value of this integral is same as the integral 1 to 2 t square dt, right? So here we have the variable x, here we have the variable t. So both the integrals are same, right? So applying this property, we can now write this integral I as minus 0 to infinity, and we have we can replace y by x, right? So we'll replace the variable y to x. So we have x, then we have log of x divided by x square plus 1 whole square, and here we have dx, right? So now we can see that this is our original integral, right? So this integral is our original integral. So we have I is equal to minus of I, right? So here this is our negative sign, and this integral is our original integral I. So we have the equation y is equal to minus I. So taking this I to the left hand side, we have I plus I is equal to 0. So 2I is equal to 0. So I is equal to 0, right? So the value of this integral is equal to 0, right? So this is how these type of important integrals can be solved by making this substitution, and then by using these type of properties of definite integrals.